Today we're learning about electricity. Before we get into what electricity actually is, let's take a look at some things that use electricity. I bet you can think of a few yourself. Alright, that uses electricity, but what is electricity? Let's take a look. Lightning, yes, it is electricity. But we need a closer look. No, don't go up there. Leave that for the professionals. That's too close. Besides, we can't see inside the wires. Get closer. Alright, that is closer. That's welding with electricity, like homemade lightning to melt the metal. So we are getting closer, but still a little bit dangerous. Now let's take a look at an old school video of what electricity is. I hope you enjoy it.
What is electricity? And that's not an easy question. To answer it, we must first think about the building bricks of the whole universe. And that includes you, me, everything there is, even this pylon. If we get in close to the iron, and then into the iron, we will see that it is built up from molecules. And then we will see that molecules are made up of atoms. An atom is so small that we really can't imagine it. It consists of a sort of central blob which is called the nucleus, with tiny fragments of matter called electrons revolving around it. Different substances have different numbers of electrons revolving around the nucleus. Electrons carry a negative charge of electricity. That central blob, the nucleus, is made up of two sorts of particles. One, protons, which carry a positive charge of electricity. And two, neutrons, which have no electrical charge. Yes, there's the same number of protons as there are electrons in orbit around it. The electrons are bound to the nucleus by the force of attraction between the negative and positive charges. But in some substances, the electrons in the outer orbit are not very tightly held, and they can be dislodged fairly easily. An atom which has lost some of its negatively charged electrons is left with a surplus of protons in its nucleus. So the atom is now positively charged. You remember the aluminum atom. Aluminum is a substance with easily dislodged electrons, and so is called a conductor. Silver, copper, and aluminum are examples of good conductors, while rubber, paper, and wax are examples of poor conductors. So although it's difficult to say exactly what electricity is, we now know that electrical effects are caused by the movement of the negatively charged electrons.
All right, let's review electricity real quick. Everything around us is made of atoms. That's pretty much everything in the world around us is made of atoms. Atoms are very, very tiny. They have little electrons, bits of electricity swarming around them. When you get them moving, you get electricity. Here's a small spark, or a bigger one in lightning. People ask, how does electricity work? Well, we put it into circuits, but they don't have to be this complicated. Circuits just means it goes around. Electricity goes around and around. Here's a simpler circuit. All right, so here's a circuit we can make at school with snap circuits. Now, this is a simple one. Here's our power, right here, the batteries. All right, and circuit means go around, so we just need to get the power from the batteries down to our motor and back to the batteries, because it's going to go around. All right, so I'll reconnect those back up. They just snap on. These are like our wires. If we look underneath, you can see they have the metal that goes through. These are just like the wires in your wall, but stiffer. All right, so our electricity, I'm going to use this blue cube to show you. Our power is in the battery, and usually I see blue sparks, that's why blue. It's going to go through the wire. Oh, there's my switch, like your light in the wall. And it's going to go through there into our little motor and back to the battery. Now, real electricity kind of goes to ground, back to the power plant, but for this works for now. All right, so I'll turn it on, and it spins. Let's give you something a little bit easier to see. Put the little fan on there.
No.
There we go. And we'll hit the switch to let the power in. Now our fan is going around. Now the switch, they're pretty simple. All it does is break the circuit. So here's what a circuit looks like without the switch. And the switch on the inside, oops, I need one bigger one. All it's doing on the inside is connecting and unconnecting. Connect, unconnect. And we can't see it, but when we turn it one way, it connects. You can see even the symbol kind of matches up. It shows you, there it is unconnected and off. There it is connected and on. Let me try drawing this out. So we'll draw the wires. So for electricity to work, it has to be moving. Nothing is happening in those batteries right now because it's not hooked up. So I draw my wire, and let's see, we'd have something over here that needs electricity. Could maybe be a light bulb, then electricity goes back. So the electricity is just going out and going around. You have to have a circuit. If something were to happen and that wire would break or get disconnected anywhere, it doesn't matter if it's over here, wherever, our light would shut off. And the switch is just an easy way of breaking it. Now people ask me, Mr. Ocon, how does electricity make that little motor spin? Well, it's tough since we can't see inside it, but the short version is magnets. Inside that motor are two things. A coil of wire, so just wrapped around and around and around and around and around and around. There's a lot. And some little magnets. Now this is a bigger magnet. You can see it's going to make these stick. So this is inside there. We'll hook up some wires to our pretend coil. When the electricity goes in, the electricity goes around and around and around before it goes back out. Well, when it's doing that, the magnets in the middle start spinning real fast. The more electricity you add, the faster it spins. And that's how our little fan spins. If I can hook it up. So you add electricity and it'll start spinning. That's it, power goes in, makes the magnet, goes around the wire, makes it go round and round and round with the magnet, then goes back out when it's done. Just like if you ever made a water wheel spin. Now light bulbs, they work a little bit differently. They don't need the magnet. So we have our wire coming in. There we go. Wire comes in. So wire going out. But inside the light bulb, or at least the old-fashioned light bulbs, you had a different wire made usually of tungsten, which is a special metal, but they can use other ones. And the electricity would go through the wire from the power plant up inside. And when it got to that top part, it would make that wire glow real bright and hot. And then the electricity would go back out, back through your wall onto the next light or plug or wherever it needed to be. So all you're doing is making that wire glow super bright. Kind of like if you ever push down on a toaster, you can see the inside glows orange. Same thing, but much, much brighter. Now, if you don't have snap circuits at home, that's fine. Whenever we get to come back, we'll try and use them. We have them at both buildings. A fun thing you can do, you can get these real cheap at the store, are button batteries and little LED light bulbs, or you can order them on Amazon. And you get copper tape instead of wires. And there are lots of plans online where you can make circuits on a piece of construction paper. I've seen people make quizzes, things like that. Now, it's real easy. Here's a very simple circuit. Here's our power, our wires, and our light. The power is going from one side of the battery to the light, lighting it up, and back to the other side of the battery. That is it. With the copper tape, which I would like to send this home, but it's very delicate and lots of issues, you can make your wires flat on the paper and tape right to the battery. It's easier if you spread these out, so they're not touching one to each side. Or you can just use a little bit of foil and clear tape or some glue. So if your parents allow, go ahead online and you can look up projects you can make with that. We'll come back next time and I'll show you some. Well, that's it for now. Thanks for watching. If you enjoyed the video, please leave a like and maybe a school safe comment. Thank you for watching.